Okay, hi everyone. I'm presenting GlastopfNG A, web attack honeypot. So, first to start, a few words about me. My name is Sven Vetsch. Some of you might know me under my nickname Discount. I have some security certification, but I don't care about it. On my day job, I'm breaking stuff for Dreamlab Technologies, a security company in Bern, here in Switzerland. And I'm leading the August local chapter in Switzerland. And I'm also an IEEE board member, so the Information Security Society of Switzerland. So that's about me. So let's start. So what is GlastopfNG? So as you can expect from the name, it's a honeypot. Yeah, I don't go into it what a honeypot is. So I hopefully everyone knows what a honeypot is. So it's based on the Glastopf honeypot. So perhaps some of you already know that project, but it's a complete rewrite. So it's a complete new honeypot, which is sought to catch web attacks, so like SQL injections, reacting on remote file inclusion, local file inclusion, whatever you have there. Then GlastopfNG is highly flexible and modular, so you will see that afterwards. Perhaps this will also for other open source projects you're working on interesting. What we did there, or what I did there. It's very easy to use, and of course it's open source, so at the end I will also give you information where you can get it from. What GlastopfNG is not, it's not a complete malware analysis solution. Don't expect to use GlastopfNG to download malware with it and analyze it and get specific output of it. But of course you can implement it in a module. Then also it's not a direct security improvement to just the systems you are already running. So they will not protect anything like a normal honeypot. And it's also, you will see, there are some similarities to web application firewalls, but it's really not a web application firewall because here we want to get attacked, and when we get attacked, we want to analyze that and not try to save our environment against attack. And it's also not ready to use out of the box, so you have to prepare it by using the rules. So you have to implement patterns to detect what is an attack and how to work with this attack. So the basic structure is like this. So here we have evil internet. You all know that. And then we have here the core of GlastopfNG, which is mainly containing of three components. We have a web server, which is the public interface to the evil internet. Then we have a pattern matching engine, which is looking for what is happening right now, what attacks are there, what type of attacks are there. And we have the module loader, which can load different modules. You'll see we have there a logo of Python, Ruby, Groovy. We'll see afterwards why this is the case. And we have the possibility to define patterns and configurations all in XML, so it makes it really easy to maintain also that stuff. So these modules are on two types. So we have action modules that actually say how you react on it at an attack. So for example, if there is a remote file inclusion, or say, for example, a local file inclusion, somebody tries to read your local etc path with you with an attack, then you can have an action module that sends back an etc path with the file to an attacker. Of course, this is a very easy example, but this is what an action module can do, and only, of course, one action module can react on one request, because we cannot send from one HTTP request, we cannot send back two requests, or we can do it, but it will not help really. And we have the report modules. The report modules can be whatever amount of modules, and this type of module really is sought to, for example, communicate with databases, writing logs, doing further analysis, communicating with sandboxing systems around it, whatever. And what is also very special, and perhaps, as I told you, perhaps interesting for some of you guys in the other project, the whole thing is written in Java, but it uses the Java scripting API, so not the JavaScripting API, the Java scripting API, which allows you to use, for example, Python, Ruby, and Groovy, and also Scala or whatever more or less language you want to use to write modules for it. And then you have a scripting engine that is written in Java for it. And so this will be directly when you start GlastopfNG. All your code will be translated into Java bytecode, so the whole thing gets really fast and also very reliable. So this is an example for how this can look like. This is, of course, only a demo example. It's the Glass Twitter module, so you might already expect what it does. It writes to a Twitter timeline and say what attacks were there. And you see this is in the centralized configuration XML. And you have module name, type of the module, and if the module is active or not. And you have some configurations. And these configurations afterwards come into your module. So this is the whole module that can report attacks to Twitter. You get everything that you need for as information from the GlastopfNG itself. So the blue and the red ones. So the red ones are directly on the fly injected into the scope of the module, so that you have this total impact, for example, for one request or one attack. The client IP address, you don't have to do any parsing or whatever in your module. So directly get that for every request that is sent to the honeypot. And we have the blue ones that were directly also injected into the scope of the module by using this configuration XML. And this makes it really easy to develop even really advanced stuff, because you don't have to care about how to get information, for example, what method is used by the attacker, what is the URI or whatever that the attacker used. So you all get this information directly from the GlastopfNG core, and then you can work with that. So this makes it really easy. The attack patterns are also very easy, though. What you see there is you have, of course, an ID, so you need an identifier to know where the pattern matched to the attack. And you have a pattern. The pattern is normally defined as a regular expression. And so you can define, for example, a regular expression that, again, a simple example of somebody tries to use local file inclusion to include ECT paths video or whatever, doing path traversal. Then you can make a pattern out of it. You can even use tags, so that you can classify it. So for example, is it an SQLi, is it a cross-site scripting, is it whatever. And then you can also use this in your module. So for example, when you want to do statistics. And you also have the possibility then to have a specific module matching to that pattern. So you have a global configuration where you say, this is my standard module. And you have a module that is specifically defined for one or say 2 or 3 patterns. So for example, when you have an ASCII injection module, you have a module that directly reacts as if there would be an ASCII injection. For example, perhaps you really have a system that runs on a virtual machine and is hosting a database, for example. So it really can react with the attacker, but the attacker will never really get out information of the system. And of course, you have an impact level, and this impact level allows you to set some bar. That if this bar is crossed, so for example, when you say if the overall impact is higher than 30, then I want to get an email to an administrator of the honeypot or whatever. So this makes it interesting to also having some monitoring solution with it. Yeah. Perhaps I answer this question because this would be also a question at the end anyway. So how does this honeypot become attacked? Mostly we're using a module that is called the dynamic dork generator, or dynamic dork list generator. Perhaps all of you know already where the dork is, or Google dork or whatever. So it's a pattern that you can search for with search engines. And attackers do exactly that. They trying to find with search engines, for example, installations of Moodle or PHP-MyAdmin or whatever. And when they find them, they will automatically attack these systems by automated systems. And we try to look like this also by every request that is sent to our honeypot will automatically become a part of the honeypot. So we react on every request. So we can use say, we dynamically add a link to whatever somebody already requested. So if somebody tried to do once a local file inclusion or remote file inclusion, afterwards we have a link that looks suspicious to be vulnerable to local or remote file inclusion. So people will then, or criminals will then be more likely to find our honeypots, and also will link all our honeypots together, or not all of them, because else if you have one you can find the others. So, but some of them will linking them together, so if you have one and go further and looking for the other pages, there are also honeypots, then also they get attacked, and so we can improve the, say, possible attack surface. So, question might also be, is there a need for the GlastopfNG? So, it's web app security, is there a problem with web app security? Who knows? So, we have a central database where we have all information from all our honeypots in there. Of course, you can run your own honeypot, but we have a centralized database. And it also has a public interface, so if you're interested in our data, it's on honeystats.info. There you will find some information on everything. And with only around 6 honeypots that running 24 hours, 7 days a week, 365 days a year, we have about 6,000 attacks per day, and we are not really doing much to promote our honeypots. So this means we really, when we go further and do more, say, advertising on the internet for our honeypots, we get even more attacks. And so I would say we really have a need to know what these attacks are, because 6,000 attacks per day, I don't think any of you have already a system, or correct me if it's the case, but where you can analyze 6,000 web application security attacks per day. And what can you do afterwards with that data is you can, of course, classic one, you can create statistics. We'll see afterward on the next slide. And we can also improve our already existing security solutions and security measures. So when we know how attackers attack today's web application, then we can, for example, do further improvements on our web application firewall rule set. We can do better input filtering. We really know how people attacking our applications. And also, yeah, this point I already include there. Also, you might have a chance of receiving really 0 days. So, for example, when you look like, say, again, a Moodle, PHP MyAdmin, whatever solution, then you might become attacked because you're looking so vulnerable that you be one of the first in the world that really gets attacked by a new, say, web-based worm or something. So this could also be really interesting. And what I will show you afterwards also that you can take something how I will show you how we can seek and destroy and all become the owner of a botnet that's based on already say owned web servers. And this is also something that is very interesting. So here a little bit about statistics. So here, for example, statistics over 250,000 attacks we have. And here, this is something that we already know, like this, from especially antivirus vendors. But how do you know their data is correct? Do you know where they get their data from? Normally, not that specifically. So here, you really know we have 600 pods. You know exactly what software is running. You can have the patterns that we have there, and then you can say, okay, where did the attackers came from? Especially here, China is not in our list, so if you check any of the statistics out there, China is most of the time about the second place if you look who is attacking your system. China is not in our list, so we don't know why, but it might be interesting. Okay, so web server botnets. So why do I mention this? Because web server botnets are interesting because they have a much higher bandwidth and most of the time more CPU than normal client PCs. They have a big uptime because this is what you want from your web server. You want it to be up all the time. And you have usually a static or yeah, a static IP address or also domain. So this means you don't need a command and control server. because once an attacker hacked into a web server, he can directly again connect to this web server because it has a public interface over HTTP. So you do not need bots that directly always connecting to your command and control server. And this makes it really flexible. So if somebody shuts down your controlling system, you just start another one and then reconnecting to all your servers. And also, normally, especially when it comes, for example, to a Unix-based system, we don't have any antivirus software on these machines. So, especially if the bots are just some little scripts, it won't get detected. So, now I want to give you 3 easy steps on how you can get your own botnet from an already existing botnet. First, what you have to say, so don't steal really dead bots or do it on a large scale, because these servers belong to some people in the world, and you don't know what people are these, and people are already perhaps really upset that their servers get owned, and so if you go in there and do some evil stuff, they might have a problem with you, and don't blame you for anything you do afterwards, after this talk. Okay, so step 1, we have to get the bot. Okay, just go to this URL and you will fill in all 60 minutes a new list of actual bots you can download from the internet. This is public, this we made available, and if you're contributing in our project, you get even access to our central database. So here, some examples. These are ID tags and PHP bots and so on. And sometimes then, or step 2, have locate bot. Of course, you have to analyze it, what it does and how it works. Normally, we have some information about who wrote that bot or who is using it actually. And much more interesting is what is supported by this bot. And normally, we have some commands to send emails, so spamming, we can do port scanning, we have the possibility directly built-in commands for TCP or UDP flooding or whatever we need. And of course, command execution, downloading additional malware, what you need as a bot hardware. And you have configuration of the bot. So I will show you that in a minute, how we're using exactly that information to really log into a botnet and also log into the bot and getting command rights over the bot. So, okay, enter the botnet. So with more time, just a small screencast. I hope you understand it, and perhaps I will also the cost on it. So it's an IRC bot in this example. So we're just connecting first to the IRC network. So very basic stuff. It's not complicated, especially when you come from low-level malware side. This is easy stuff. So this is nothing really special, but it's very easy. And why do the hard stuff when you can do the easy stuff? So what we do afterwards, we have to name ourselves just like one of the zombies, one of the bots, because if you don't do that, you will get directly kicked out of the channel. So we're just naming ourselves like the bot. Then we are logging into we're joining the channel where all the bots are in. Yeah, and here we go. So we are logged in. Also, these are not normal people. This is just a bot that names all our zombies with a huge array of names, so that it looks not that suspicious like having zombie. And now we have the user command. User command is normally used to log into that bot. So we already have the password because our bot we downloaded before must know how somebody can authenticate himself to this bot to show, hey, I'm your bot herder. And we have the password, so we can just, what we did here, we have a password in the configuration of the bot we downloaded. So we just sent it to the channel. We can also directly send it to one zombie, but it's much more fun if you do it for all of them. And then, as you see, we are now logged into all the zombies we have here. And here to work, this is the command. Normally it's called info, but here's they changed a little bit the bot code. And here we see, for example, what we have. We have a Fedora, we have a CentOS, whatever. We see where this is located, we see the address, we see domains, and we can do more or less what we want now. Now we have complete control over all the bots. So it's that easy. And so for example, we can execute UMI, so we see all of the bots are executing it and we get back. And something you can do is very much fun, is the last step. A command that nearly every bot supports is the so-called die command. And the die command makes all the bots disappearing from the botnet, and they will not reconnect. So they really have to do all the attacks again, and now the bots all logged out of the botnet. So the botnet here is destroyed as long as they do not doing all the attacks again. So it's really annoying for them, I think, but I don't care. Yeah, this is the way you do it, and yeah, I have only 20 minutes, so this is the last thing for it. So if you want to try your own, either getting your own botnet or trying out the honeypot to really also get this information yourself, you can go to dev.glastopf.org, and there you'll find all the information. Make sure that you're downloading the GlastopfNG version and not the Glastopf version, because this is the old version that is no longer really under support. And then you can do whatever you want. So, and yeah, so now I'm happy to answer your question. There are any. Yeah.
So destroying botnets for fun and profit is always fun. For example, the botnet you just took out. Do you think that the you will hinder them or cause them a lot of trouble because they know where the bot has been and they can probably infect the site just as easily again?
Yeah. So
what do you think about that?
Yeah. So the question was if it's not just possible for the bot herders to reconnect because they know the vulnerabilities they already used. And so if all the bots disappeared, why not just using again all the attacks and then getting back control over the botnet? Of course you can do that, but the die command is just something that is annoying because normally they are not prepared for it. So it normally takes them, say, about 2 hours to get back all their bots. So it's just annoying, but why not using the change iris command? Then they will change it, and then you getting to rename it, and perhaps even doing an input filtering, implement an input filtering for the infected bots, so they cannot using again same stuff. So I think if you really want to take over a botnet and want to keep control, it's no problem. Die command is, as I told you, just annoying for them. Any other question? Yeah.
For the statistics, your 6 honeypots, what types of domains are they serving? Only .ch or international?
No, we have international, and especially I have to say 6 honeypots. Doesn't mean we have only 6 IPs they're running on. We have, for example, we are working also together with in Germany, 1&1, big ISP, and they have, for example, for the config warm, they reserved a whole bunch of domains. And really, I don't know, perhaps thousands of addresses. And now, on many of them, if you contact them, you will end up on a GlastopfNG. So we really have a huge amount of, say, possible ways to come to one of the 6 honeypots, and we have all kinds of international domains. Anything else? Okay.
As we're running out of time anyway, we will still be around for another hour or 2, maybe 3. So anyone can ask Sven a question, I'm sure. Other than that, thank you, Sven.
Yeah. Thank you.